This video is going to cover lesson 5.7, which is on dividing polynomials. And we are just going to focus on the basic division of polynomials. So either a monomial divided by a monomial or a polynomial divided by a monomial. We're not going to have to worry about doing any long division with polynomials during this class. So just focusing on the basic forms, again, a monomial divided by a monomial, that's what our first two examples are going to cover. And essentially it's going back to using those rules for exponents. So that's the idea here. So we're going to look at the fact that on this question, we have this negative 108 over 27, and then we also have this z to the 36 and this z to the 12th in both the numerator and the denominator of this quotient. Those are like bases, and we can actually do this division here. So this negative 108 divided by 27 is going to give us negative 4. And again, using our quotient rule for exponents, we're going to subtract these exponents. So 36 minus 12 is 24. So this is going to be z to the 24th. And we just completed that division question. So if you know your rules for exponents, you're going to be able to do these questions. And again, if you're still struggling with those rules for exponents, you need to go back and review the material from lesson 5.1. The next example, number 4, is going to be the same idea. We have a monomial divided by a monomial. And we're going to basically group the like bases into individual quotients. So you could rewrite this out as 72 over 8 times t to the 4th over t to the 9th. Or again, you can kind of do the process that I've done, which is just to circle the like bases. 72 divided by 8, that's going to end up being 9. And just like the previous problem, we're going to subtract our exponents because that's following the quotient rule for exponents. So 4 minus 9 is negative 5. So we have t to the negative 5. Now, just like the previous lesson with all the negative exponents, again, we don't want the negative exponent on here, so we do need to rewrite this as 9 over and then t to the 5th. And that would be the final answer for this division question. Now, when we move on to the next set of questions, these next examples, they do get a little bit more involved. But essentially, we're still going to be dividing by a monomial. We just have a whole polynomial, in this case a trinomial, that's being divided by it. So to do this question, we're going to break this apart into each separate quotient. We're going to do 12m to the 4th over 4m minus, and then we got 16m to the 3rd over 4m plus 32m squared over 4m. So now, this is just going to go back to what we just did in the previous question. We're going to simplify each of these using those rules for exponents. So this part here is going to turn into 3m to the 3rd, because 12 divided by 4 is 3, m to the 4th minus m to the 1st power, right? Or, divided, we're going to subtract those, so 4 minus 1 is 3, minus 16 divided by 4 is 4, and then m to the 3rd power over m, that's going to be m squared. Again, subtracting those exponents. And then this last part here, 32 divided by 4 is 8. M squared over m to the 1st will be m. And that's as far as we can go with that question because all of these are unlike terms, and that's the division for that question. The next one's going to be very similar, except for now we have a binomial divided by a monomial, but the setup is going to be exactly the same. So we're going to start off by doing negative 10p to the 5th over negative 5p to the 4th. We've got a plus sign in between, so we'll have a plus sign in between here. 75p to the 4th over negative 5p to the 4th. So now, we just need to simplify each of these. Negative 10 divided by negative 5 is going to be positive 2. So this will be 2p. You could write the first power here, but you don't need it. And again, that comes from doing 5 minus 4. And then we're going to have minus 75 divided by negative 5, so that's going to end up being a negative 15, so that's why I wrote the minus there, so minus 15. And then p to the 4th over p to the 4th, again, there are a couple ways you could think of this. If you just use your quotient rule, you'd say 4 minus 4 is 0, p to the 0 power is 1, or you could think of it as, again, a fraction. If you have the same thing on the top and the bottom of that fraction, the numerator and the denominator are the same, it equals 1. So 15 times 1 is just going to be 15. And this ends up being the final answer for that question. And then the last example, there's really not a ton of questions within this section on dividing polynomials, but this idea is going to come up later, so make sure you do take the time to practice at least a few of these questions. And the last one, again, is just a trinomial divided by a monomial. So it's going to be very similar to what we just did in number 6. So we're going to break this apart so that it says 8w to the third all over what we're dividing by, this negative 2w squared. We've got a subtraction sign on the top, 14w over, again, a negative 2w squared. And then we got a plus sign, and then 6 over negative 2w squared. So now, when we go through and simplify this one, 8 divided by negative 2 is going to be negative 4. And then the w cubed over w squared is going to give us w. And so that part's done. Here we can keep it as a subtraction sign for now. We will end up having to change that because 14 divided by negative 2 is a negative 7. And then w over w squared, again, subtracting those exponents, this is 1 minus 2, so this is going to be w to the negative 1 power. Plus, and then 6 divided by negative 2 is going to be negative 3, which is the same as negative 3 over 1, so the negative 3 is going to be on top while the w squared is still on the bottom. And then their last step is just to clean this up a little bit, and again, we don't want this negative exponent. So this is going to end up being negative 4w plus, and this is going to be 7 over w, because again, this w is the only thing that has the negative exponent, so that's going to flip underneath. And then we can write it as minus 3 over w squared. And that would be our final answer for that division question.